All right, y'all, buckle up. This is about to be a quick section. Section 10.3, Displaying Data, Part 2. Back in the last section, we talked about most of the graphs. For some reason, in this one, they just decided to put line graphs and scatter plots and, and multiple line graphs all together. I don't know why, but you can see this is about to be short and sweet. So buckle up. Line graph. This is also sometimes called a time series graph. These graphs are used for showing trends, specifically over time. So, for instance, a lot of the line graphs that we've been seeing lately have to do with COVID cases, right? So, you can easily modify a line graph like this to make it more misleading, okay? If you change the scale, look at these two graphs. If we tell you that the new COVID cases per each month in a particular town, which one of these graphs looks scarier? Right? Well, this one's like, oh, well, it's not too bad. This one's like, holy crap, it's climbing. Depends on the scale. Look over here. I've got this set up to go every 50. Over here, it's going every 100, so it's a lot flatter. If I made this every 150, this would really be, really super flat. So you just have to pay attention to the scale. It needs to have a scale because a lot of times this kind of stuff, if someone's trying to mislead you, like say a news outlet or something like that, or a newspaper or journal or something, then they won't even put a scale over here. So that's something to think about. Oh, just in case you're wondering, that's January, February, March, April, May. In case you're wondering what those weird letters are. Okay, you can use a multiple line graph. That's used to show similarities or differences in data over the same period of time. So I made one up of just like the population of town A, B, and C. A lot of times we've been seeing a lot of these kind of graphs of new COVID cases in the United States, in the UK, in Germany, in Canada, things like that, right? To kind of compare them. So I just did this as the population in thousands, 5,000, 10,000, 15,000. So you can see I've got a scale over here. And I did them in different colors so they were easier to tell apart, that you can more easily tell that town C had a decrease and then it's back on the rise. Town B has been increasing faster than town A in population. Now, the other type of graph in this section is something called scatter plots. We're not going to bother covering that. Okay, that's just way beyond the scope of this course. There's really no point in doing those. I don't think that kids are even going to see these until high school. So there's just no point. So we're not even going to cover that, which means we're almost done. Told you it was going to be fast. All right, example 1 and only. Choose the most appropriate graph type. Use each graph only once. So I'm giving you 4 types of graphs and 4 different scenarios. So I want you to pause the video, take a second, and see if you can, well, it might be, I'll have to scooch this one down, but go ahead and pause it, see if you can do these 3 and figure out which one of those graph types is going to fit in there. Which one's the most appropriate? Use each one only once. All right, your monthly bill is broken into 7 categories. What do you think? I mean, the fact that it says categories kind of maybe says bar graph, right? Because we said that that was really good for categorical data. Yeah? But then again, this is, monthly bills split into categories. That's really good for like taking parts of a whole, right? To be able to look at a circle graph and see how big of a sector your rent may be, or your phone bill or cable bill, or utilities or whatever. So this one's going to be more of a pie graph or a circle graph is the most appropriate one. So it's not to say that a bar graph is the wrong answer, but given these scenarios, the pie graph is most appropriate for this one as opposed to the others. All right. A list of 6 different makes of cars and their corresponding miles per gallon. What do you think? Bar graph, line graph, or histogram? Well, it's categorical data, right? Because it's makes of cars. So you're not going to have like a car that's like half Honda and, you know, half, what, Audi? That abomination's not going to make it on the road. So it'd be kind of cool though if it did have little hybrid cars like that. But, so anyway, that is going to be more situated for a bar graph. Okay? Now, you may think, well, a line graph might be okay, right? But a line graph implies that there's in-between data, and there's no in-between data here. This is very categorical data, and it's not like a part split into, or sorry, a whole split into parts, so it's not going to be a pie graph. This one's going to be best suited, this data is going to be best suited for a bar graph. Okay, so we've used bar graph, and we've used pie graph. So we have line graph, or time series graph, and histogram. The age of a car in years and the corresponding number of dollars the car is worth. Okay, here's your clue. In years. Line graphs are traditionally used for time. So that's your hint. This guy right there. So that's what makes this a line graph or a time series graph. Anytime you're measuring something over the course of time, that's a dead giveaway. All right, well that just leaves the histogram. So the list of the top 200 times of Chicago Marathon runners that shows the number of runners at each time interval. All right, what's the clue in that it's a histogram? That word right there, interval. Right? We know histograms have data, numerical data that is grouped into intervals. So that's what makes this one best suited for a histogram. Okie dokie. So that is going to finish up section 10.3. Told you it was going to be short and sweet. Enjoy it because the next one is not. Ugh, I'm dreading it.